Hey everybody. Just gotta get my tweets out and everything. 1 second. Hey Clayman, back to the stream. Getting some pretty bad mouse lag, so let's see if we can survive. Survive this stream here. Might need a reboot. I don't know about y'all, but I got real case of the Mondays. Alright, come on. Well, let me get a whiteboard going and we'll talk about what we're up to today. It's time to attack the secondary indexing. If you saw the last stream, you know that we did a pretty big rework of the internal database design to deal with the fact that it's a distributed system. We switched from usernames to user IDs. We switched all the internal links to using hyper URLs, which are global, and more importantly, use public keys for their domains, so that if users change their user ID, their data won't get broken. So permanent links internally, which is good. And so with that out of the way, we need to hit secondary indexing. Hey Ryan, welcome back to the stream. And for secondary indexing, the trick here is basically the way that you would normally build an application like this. You would set up a single database, like a Postgre, and you'd use SQL to create a set of indexes. You might create some triggers in the database, or maybe you do it outside of the database to do things like populating a notifications table, things like that. But one of the things that's sort of, you can rely on is that you're in control of the database. So you could do things like transactions that cross multiple potential provenances of information. For us, not only do we not have a single database, every user has their own database, but they may do the writes somewhere else and then just sync the data to us, which means we don't actually have an opportunity to enforce any constraints other than what we sort of negotiate with our schema system. So it kind of changes the mental model a little bit, where, you know, when you're building a web server, you tend to build it so that any input you receive is untrusted, right? Like if somebody posts a form to your server, you don't trust it. You validate the heck out of it. But then when you're reading data out of the database, you know, you kind of think of that as being inside of your perimeter. It's validated, handled data. That's not the case here. In our system, because the data layer itself is networked, the database itself is networked and decentralized, basically records that you read out are untrusted user messages. And we have to construct the whole thing around that. Hey, Todd. Welcome back. So, one of the other effects of this is we have to choose how to handle secondary indexing in general. At the moment, we're doing a pretty natural thing, which is whenever the user runs something like put comment or add comment, we do things like update the indexes. That can't... It's not that we can't do that, but it's just not the only way, the only pathway by which comments will get added. Let me get a whiteboard going. If anybody has a good whiteboard app. Don't really want to sign up or anything. I just need a simple whiteboard app. Just give me something real dumb. This sounds like it might be the right vein. Okay. All right. So we got I have to learn this app as I go. So you got these two Hyper-Bs, right? And this one is called the server Hyper-B. This one's a user Hyper-B. And this is the server itself. This box represents the server perimeter. So they may actually be on the same server where everybody lives kind of together, and the client lives over here and is sending messages back and forth to the server to get things done using our RPC, our API right here. So that's how this could be structured, in which case whenever the user does a put, the server code, which this, you know, the server over here, come on whiteboard, can actually handle all the updates. No big deal. The question is, how do we deal with a situation where you've got your user Hyper-V and your server Hyper-V, and here is your, okay, this tool is kind of helpful but kind of not. I gotta figure out what the fuck with some of this. So you got this situation here where you got the server and the user device separate. So this is the server Hyper-V and this is the user Hyper-V, and they're synchronizing not using RPC but using HyperCore itself. And in this scenario, you have to set up a solution where the server is watching for those updates and updating any secondary indexes it maintains. And there's a couple of ways we could do that. We can do it by having the server basically maintain a registry of all of the Hyper-Vs that it's interested in, and periodically fetch the latest from them and update the secondary index. So you might call that an active pull solution. So that's one option. The cat is just, I don't know if y'all can hear the cat, she's just going on, writing a novel. So there's active poll. Another option is that we could do is just-in-time indexing, which is something that Matthias was suggesting yesterday. So active poll would be a sort of active, ongoing. What's this thing? Whoa! Don't want that. Active poll would be where you just iterate through all of your Bs. So you got your list of Hyper-Bs right here, and you got, I'm going to draw an eye. You're constantly watching them, right? And then on a change, you write them out to your secondary index. So that would be active poll. So that's one option. The other option is you have the server here, kind of like a desktop computer. And whenever a client makes a request, it will then look at each of them and say, basically do a check against their current state and the index. And if the current state is behind the index, or excuse me, if the current state is ahead of the index, it would then update the index and then respond with that. So that would be just in time. There's a couple of advantages and disadvantages to active poll versus just in time. On the plus side, active poll ensures a relatively predictable request speed, because all a request is going to be doing is fetching off the current indexes. No big deal. The other thing that's nice about the active poll is that it's keeping the Hyper-Vs updated sort of on their own. So like if I'm accessing server Hyper-V over here, and I'm doing that using the HyperCore protocol rather than doing RPCs to the server, then we're in a better situation, because it's going to be keeping its database up to date. So any secondary indexes it's publishing will be kept up to date. That may end up being an important factor here. In fact, it may end up being the most important factor. Because one of the things we have to figure out here is exactly how much we want to rely on the RPC API for the functioning of the network. An interesting example of this is, well, let's put a pin in that and come back to it because it's interesting. So like how much we want to actively be publishing secondary indexes on HyperCore. So active poll keeps your secondary indexes up to date constantly. That's a really nice benefit. The other benefit of active poll is a little bit easier to implement, in my opinion. And I've implemented this like 4 times now, so this, got that upside. It's also kind of important because there are some things that need to be updated passively all the time, like notifications. So there's that. Just in time. What are the upsides to just in time? One of them is that you're not producing any secondary indexes that aren't getting used, so that's nice. So if a user followed 1,000 people but then never logged in afterwards, the server would be able to kind of like, all right, well, that person's not using the thing. That said, you don't actually know if the user is using their thing because they may be interacting entirely through the hypercore protocol. It's actually possible. So I don't know if we can fall back on basically the last time you logged into a server as a real indicator as to whether or not you're using the server. Yeah, I just don't think just-in-time is going to work for this. So let's talk for a second about like the upside of how hypercore factors in here. So these boxes represent servers. And so each of them have a Hyper-B. I wonder if we can do like a shape in this thing so that we have something more interesting to look at than a circle for the B's. Looks like... not sure what those do. Okay, I'm not saying any shapes, so that's alright. So each of these will have a Hyper-B. Evan asks, couldn't you use an event system built into HyperCore to detect when feeds change? New blog. Maybe I'm not understanding the problem. No, you definitely can. The discussion between whether or not to do active poll versus just in time has to do with characteristics other than the challenge of knowing if data has changed. It has to do more with passive or active background processes that are constantly doing indexing versus trying to kind of minimize that background processing by doing things just in time. Matthias also has suggested he thinks that it might be easier to implement just in time. I'm not sure that I agree about that. So let's talk about this. AJ Whirl, welcome back to the stream. So one of the interesting things that we're looking at with the design here is the interplay with how the whole network will operate. Because we have this design of communities that are server-based. And we want to make it so that people can easily deploy their own communities. And among the many challenges that come with that, one of the things that folks that have ever done like Mastodon can tell you is that maintaining the server can be actually pretty difficult. There's a couple of ways we can counteract that. I'm going to try this thing real quick and see if I can't use it to quickly like draw. Okay, so there's the center. In theory, I should be able to like quickly throw together interesting shapes with this, but I don't know if I can. Okay, that's not super helpful. All right, so one of the things we could do here is have an application. I'm not going to try to spell with. There we go. Perhaps it'll be citizenread.com. Okay. Sorry, I should have learned my tool before I started using it. And this thing will be able to speak to multiple different servers. This is the front end and back end disconnect that we were talking about last week, and I think we're going to go through with it. So we are able to then have people set up communities without having to run the front end at all. The front end and the back end will be separated. This means that you can have lots of different front ends where users have some choice on what the front end is, but still maintain use of a given server. This means that the servers are really designed to do a couple of things. They're meant to be identity providers. They're meant to be aggregators. They probably are meant to be sort of community I guess I would say community authorities. And I've gone a little bit back and forth on whether or not I think that aspect of it, the community authority part, ought to be sort of baked into the server. But if we make it so that servers are very simple to set up and don't cost a whole lot to set up, then people should be able to create their own communities. If it can be as close to like setting up a new subreddit as possible, we're in a good place. So a major consideration on that is cost reduction. We want to set it up so that not only can anybody set up a server, but you could do so with like ideally like a $5 to $10 a month like DigitalOcean droplet. So that's an interesting challenge. One of the ways that we could possibly handle that is, suppose you set up a server that gets some really popular user on it. If you're having to serve all of the content directly off the server, like using something along the lines of the RPC API, and suddenly your server is getting 10 million requests a month, and it's too much, and the thing is failing, that's a problem. Suddenly you're having to scale up the server, and users having to scale up their individual servers is a bit of a deal breaker on self-hosting. So this is where the hypercore protocol can become useful for us here. Because one of the servers involved here, maybe this, let's say server1.com is, a mom and pop situation, but server 2 is professional. It's a commercial that's designed to scale up really heavily. Then what it could do, the way we could organize this, is to have this server right here synchronizing server 1's bees. And so in a design like this, you still have the authority autonomy of the server1.com, where it's maintaining its own databases and all of its resources are purely dedicated towards simply maintaining its own data sets. But the cost of hosting to a large group of people can be distributed out into the network. In fact, we might even get into a situation where each of the servers involved are able to rehost each other. And in that scenario, they only have to deal with the scaling costs of their own user bases. So a large part of what we're talking about here is trying to avoid having the hosting of a single server become an onerous cost if its content gets popular. So to some degree, what this suggests is it's a little bit useful or important to avoid building our thing so that it relies too heavily on using the RPC API to the server that data is coming from. For instance, if I'm over in my app and I'm on, let's say I'm pfrazy at server2.com, that's me. I'll highlight it to kind of... So that's me there. And I'm following Bob at server... Oh, what's the color doing? Come on. This app. It's so close to being just perfect for me, but not quite. So I'm following Bob at server1.com. Ideally, since I'm homed at server 2, I'm not calling out to this RPC API. Ideally, all of my requests are being sent to this one right here. And then it's communicating with server 1 to get the data for me. That would help us avoid basically the situation where the RPC APIs are getting overloaded because your mom and pop server suddenly started hosting popular data. So that's kind of what's on my mind as I'm building this stuff out, is thinking about just exactly how much of the RPC API we should be using and how we should be designing it. Should we be expecting everybody to be talking to one home server, or should we expect them to talk to lots of different servers? And I'm sort of inclined to think that if you're using the RPC API, you have what I would call a kind of a contractual relationship with them. As opposed to like whenever you're hosting something anonymously, publicly, there's no contractual arrangement. If I'm just doing a get against somebody's server, I don't have any kind of arrangement with them. They're just hosting, openly. And if you always have a sort of like I have an account with the server, there's metering that can be done, and that server can stop accepting new accounts to ensure that it's not getting overloaded. Now, the downside of this approach would be that anytime a user on server2.com wants to access something from server 3 or server 1, then the server 2 has to sync it from those other servers. But I think that's still the right trade-off to make. To some degree, I'm explaining, and to some degree, I'm thinking out loud, so I hope this has been followable. We'll see if that ends up holding up, but definitely the meta goal here is to distribute load throughout the server's network as evenly as possible and avoid any kind of decision that causes one server to suddenly get swamped. And probably one of the best ways to do that is to ensure that fetching information is not naively just going to whatever server is the home and asking for it with a live connection. I've got a bunch of pings here, so let me just check into these real fast. Okay, I got somebody in IRC helping me out with this. So Ryan is suggesting a UML thing. Yeah, that's not bad, except it's textual, which, I don't know, maybe that's the right call. I like to be able to draw on the thing, but there's definitely some benefit to this. Just need to learn the syntax. I don't know, let's try it here. I don't hate it. Yeah, it's not bad. Wonder if I can do this. I suppose this is a little bit easier, huh? I can't dual locate the databases, which is unfortunate because they logically are. Well, I'll spend some time futzing with the tool choice here because definitely this is a little hard to work with. I think it's crazy we don't have better live whiteboarding stuff. I would love to give talks this way if I had just a really nice tool that I could be a power user with. Anyway, I'll have to spend some time researching that. All right. So I guess now I'm pretty sold on doing active as opposed to just-in-time syncing. And so now we got to think about how we're designing that. This has some promise. Yeah, I'll try this out. All right. So we have now we got the user DBs and we've got the server DB. And now we need to be producing secondary indexes. So the secondary indexes are going to need, you know, I got a whole lot of code that I wrote for this. I've written, like I said, I've written this sort of thing, this secondary indexer for the hyper network. I've written this about 3 or 4 times now. And in fact, one of the things that we had in Beaker before I threw it all out was a built-in secondary indexer. And if I go back in time a little bit, I could find right there, remove the indexer. This is the commit that I nuked it. So I think it would be wise to refer to this a little bit to see how the heck I structured this thing. Alright, so I think we're right about here. This is the point in the history where it was still in its full implementation. So I was using SQLite to store the actual thing, and what we can do here is get a good look at how I structured the tracking of the indexing state, which I think will be important for getting this right. So I had this concept of the indexer state, which is a general key value store that I used. I had the individual sites, the individual hyperdrives I was syncing from, and I was tracking the version of when I last indexed, but I think I changed that over time. Because eventually, a couple of migrations here. There's a couple of things that we have to think about. One is whether or not we have indexed. We're going to basically be producing multiple different secondary indexes. And each of them can be, let's say we have a set of secondary indexes that have been going for a while, like comments, but then we introduce a new one. Like maybe we want to have a secondary index that is produced for all the people you follow, producing a user feed. Well, that thing's now starting from scratch. So we need to actually track the indexing state of each secondary index per secondary index. So every Hyper-V, every hypercore structure has a sequence number that increases, so we can track the last index version by tracking that sequence number. There's also a couple of different ways that secondary indexes can be defined here. And this part gets a little challenging. Comments, for instance, are really straightforward because all you need to do is populate a tree, and it's really straightforward. You have a source set of users, they have a set of comments that they've created, and in a kind of a functional aspect, there's a very direct, okay, read the starting set, and that outputs a output set. So it's kind of pure functional. And most of the indexes work that way. Most of the indexes are purely functional. And you could actually even define them that way as just pure functions. And that's very clean and easy to do. It's not always the design of the secondary indexes, though. For instance, notifications are terrible for secondary indexes. Because there are, first of all, you need to track whether they've been read or unread. That's a pain. They have logic around who you're currently, what rules are in place. So has somebody been muted, for instance, or did you block somebody? Well, then all notifications from them need to get cleaned out. Now, we may be able to define notifications in a functional way in every regard except for the read or unread state. So that there is basically a feed of sort of events that have occurred that are time ordered, that are functionally derived from the user's current configuration. But then we just have to have an intelligent way of dealing with read or unread. And you end up getting some interesting challenges with that as well. I mean, suppose notifications are just hard. Because suppose, for instance, there's a giant question around it as to how the notifications reach somebody in the first place. In a decentralized system, we don't have global vision. So somebody could be talking to you, replying to your comments, but you're not following them, and they're not on your server, so you don't know about it. And I think the challenge for us is to build this thing in such a way that it actually takes that quirk of the network and turns it into a feature. In fact, I'm sort of inclined to think that the way we will structure this is that as an end user, I'm choosing to follow individual users, and I'm choosing to follow individual servers, which are acting again as kind of communities. And I will check, probably the people that I follow will get indexed into a personal index for me by my server, by my home server. And I suppose the same would be true for notifications on comments and things like that from the servers I follow. But what that would mean is that whenever I'm looking at a post and it's showing the comments, I'm going to see comments by anybody that I'm following, which can be anybody in the world. And then I'll see comments from the communities that I'm following. And that will be the full extent of how information transmits through the system. Which likewise means that if somebody does something that should ping me, that should result in a notification, they need to either be in a community that I'm in, or I need to be following them. And if we're not in an overlapping community, I won't see anything from them. I think that's the right way to do this. What it sort of means is that, like, pushes or, like, reaching somebody is either because they have indicated personally that they're interested in receiving things from you, or it's because you're in a shared community space / shared moderated space, which communities are meant to be. And that seems like a healthy design for this. But there's never any kind of notion of a global space by which pushing can occur. So if I'm not connected in any meaningful fashion to somebody, like I'm not in a shared community with them, and I'm not already following them, and they follow me, I just won't know about it. I think that's the way to do this. If you do it any other way, you actually end up inviting another form of centralization. Because if you try to set up a situation where you have global push notifications, so to speak, like I want to know if anybody in the world follows me, what you're going to need is a indexer in the system that is trying to crawl all the data. But of course, there's no such thing as a global index. I mean, you could certainly do that. You commit a huge amount of resources. But nobody actually expects that design, because if you actually did that design, what you would get is an endless amount of spam and abuse and what have you. So everybody sort of expects aggregators or indexers to be opinionated and to do a sort of opinionated pass on who they include and what kind of content they include. So I think we'd be better off if we surface that as a concept of a community and had multiple different communities that you were a part of, and it became known that that's how people reach each other. I know I'm really freewheeling today, but hopefully some of this makes a little bit of sense. I'm going to grab some more coffee and then sit back down. Yeah, I mean, normally I come into the streams knowing a lot more what I'm about to do for the stream, but this one I really just have to talk this stuff out because I'm not sure yet. Paul says it sounds correct. Paul Rodwell. I think it sounds right to me. It's getting the right blend of like personal sort of independent decision making and community decision making. Because you can manually follow anybody from any community and you'll get information from them. So that's how you span any topology of community organization. But once you get into decisions that are not individual decisions, you're now into collective decision making. I think that needs to be community oriented. With communities of varying sizes as well. Which, of course, then leaves a new interesting question, which is how do you discover communities? And probably that's something that gets pushed onto the app makers, which is a powerful position to be sure. Again, you can always just look up any community you want. But I imagine when somebody sits down to, let's say, citizenry.com, let's say that's our front-end app, and they're just getting started, and they maybe don't know that many people, and they're hey, clicking around, I want to figure out what I'm doing, find interesting communities, you probably want something like citizenry.com to be saying, okay, here are the lists of interesting communities. And in that scenario, you really want to have some kind of standards to be applied. This gets into the same problem that like Facebook had with like group recommendations. But on the plus side, that is like one of the few opinions that the app would have. So it's an interesting sort of political organization that we're talking about. Let's draw it out, actually. Let's try again here with the new tool. So you've got the front end app. And then you've got the communities / servers all over here. And then you've got the individual users. Okay, this tool's not bad. So you have over here community recommendation power is something that the front end app has. You've got community management, moderation, community management and moderation power over here. And then you have the individual following power and that right there. So each of these are sort of interplaying with each other. And of course, there's not just one front-end app, actually. There would be a variety. So that's kind of the political arrangement that we're creating here. Users have individual choice and some amount of versatility to act on that. Communities are being somewhat governed by the front-end apps in terms of whether or not they're getting recommended. And if they're not public, if they're sort of meant to be private communities, it's no big deal. People will share those things with each other, generally. But if it's meant to be a public server, like the Texas Socialist Party or something like that, and they want to get promoted, then they're going to have to follow whatever kind of guidelines the front-end apps have for promoting those things. So in a way, the front-end apps are kind of applying a standards expectation for the communities without actually handling the community management itself. Just kind of like, what do I expect out of you? Well, I expect hate speech to not be allowed on your community. I expect, laws to be followed. I don't expect there not to be illegal content, things like that. And a front-end app could also farm that decision-making out to something. There could be some kind of server or community somewhere that they're pulling their recommendations from. But it is a breakup of power that I think is the right approach. Okay. At this point, I'm not sure if I'm actually doing productive work or just avoiding productive work. Oh, gosh. All right. You can tell how excited I am about starting on the secondary index design. What secondary indexes do we currently have? We've got the user database one. We've got votes and we've got comments. Those are the only, and follows. Those are the only ones actually being used at the moment. Oh, man. So we need a meta table. Which is the index state. And these will be tracking you got the schema ID, of course, which is it's a string that looks, like these. So it'll be values like comment IDX. So that's the schema ID. What else? There's going to be the subject. And we could just stick with this where we track both the database URL and the user ID. But I actually don't think we need to. I think it could just be the database URL. That said, though, let's actually keep it as an object. And rather than tracking the user ID, we're going to track the last indexed sequence. And we'll track when it was last updated. I think that's all the information we have to track for a given item. For a given, so it's basically a pair that we're talking about here. For a given schema, for a given index, such as the comments index, we're tracking for each possible subject of indexing. Where are we on the secondary indexing process? Which also means that we're talking about a key name that's like probably a concatenation of the schema ID and the subject database URL, which is kind of ugly. Because we want to be able to say, like, all right, our index states. This is going to be something along the lines of like, all right, for citizen.network/comments index and some given database, get the current state. Those are really long keys. So I don't love that. We're talking like, what, you know, this is going to be somewhere around the line, along the lines of at least 64 characters plus the schema thing. So, you know, 64 plus probably another 20, 84. And then for what, 1,000 users, we're talking about 84 kilobytes for just tracking a single index. And this is just the keys. We could turn subject into an array. Which would mean that we're reading and writing a giant JSON blob every time the indexes get updated. I'm not sure there's a way around this problem. I mean, we could always introduce a kind of compression where we map the schema ID or the user key to a ID in some kind of table. That might actually be wise. Kind of a pain, but we're talking about information which really only the server process cares about. I'm gonna use the bathroom real quick and mull this over. Okay, that worked. Help me come up with my answer. I'm going to ignore this problem right now. We're going to be inefficient about the data storage. Get it correct and then worry about the disk usage here. So this is how these will be indexed. I'm tempted to change database URL to database key to get rid of like the hyper://, but I feel like that's asking for trouble. Should use URLs whenever possible. Okay. Oh, gosh. So this is going to be a common requirement for databases to have this indexing tooling. So I think it's going to be in the base class rather. And so like if we look at, for instance, the votes index here, this is the basic logic that needs to get run every time the set of kind of watched databases changes its votes records. we have this change record, which is telling us whether or not a record got put or deleted, and then telling us information about what that change was. And so we sort of need to, what we need to do is wrap this in some code that is paying attention to and tracking where in the database history we are, and basically avoiding duplicate index updates for a given change. The other problem is currently this is only triggered whenever votes.put or votes.delete gets run, right? And we can't do it that way. We could certainly trigger it at that moment to make sure that the indexes are updated before votes.put is finished. But we also need to be watching the databases and actively watching for changes, because they may have been changed remotely and we sync it down. Ugh, this is just such a ball of hair that I'm really having trouble finding my entry point into it. One second. I'm trying to quit nicotine vaping. It's very hard to do whenever you're trying to do mental work, because that just depresses your brain a little bit, and so I'm going to have to progressively draw down on this, but need my brain working right now. Okay. Yeah, I don't recommend nicotine. It's a huge productivity enhancer, and then it becomes a problem. My vaping is why I have to mark my live streams as not suitable for children. That and probably cursing. Okay. So let's step through what the heck we're doing. We need to have a process for watching all databases. This might be user DBs, it might be server DBs, ours and other servers. On changes to relevant records, we need to trigger secondary index updates, but we have to find the secondary indexes which are affected by the records. We also need to side requirement when the server is updating a DB should trigger and await secondary index updates. So index updates should pull the current index schema source URL metadata, check to see if changes have occurred since the last index update. If so, apply all changes. Actually, I'll reword that to fetch all changes that have occurred since last update. If so, we apply all those changes and we update the current metadata. If any update fails, abort. Which means that we update the index metadata per applied change. Now that introduces an interesting situation where, like, why is the update failing? And if it's failing because the data is malformed, we need to move past it and just ignore it. If it's failing because it can't access the data, maybe the network is down, then we need to stop and wait until we can get the data and then resume from where we left off. Notice I'm suddenly able to write all this as soon as I hit the vape. This is exactly what I'm talking about. It's bad. It's also why I was slow to start today. I have got to get off the nicotine. Okay. So if we break down what all we have as our tasks here, there's the DB watching. There's the mapping primary records to secondary indexes, which need updating. There's the index metastate tracking. There's the index definitions. Now, these two pieces right here, I'm going to number these so I can talk about them. One and two are actually relatively trivial. 3 and 4 are the ones that get a little more interesting. Because in an ideal world, 3 and 4 would actually be defined in our table schemas, right? Like, it would be really incredible if none of that logic were actually encoded into the server, but were entirely encoded into these JSON files. That would be akin to what we expect out of, like, if you're able, like in Postgre, you can do a lot of that way, right? And to do that, though, they use, if you really wanted to do the equivalent in Postgre, you would actually have to go pretty deep into things like defining triggers. And you might even end up writing like PL SQL to do so. We may not have that at our disposal here. We could go totally nuts and start trying to define code in the JSONs. And I looked into that a little bit. There's like the Agoric team has been working on trying to create secure versions of JavaScript for their smart contracts and their own blockchain kind of thing. And they made this thing called Jessie, which is like a subset of JavaScript. That would be really interesting to use as a database language. But I'm a little wary of diving in on something that's as novel as that. I dug around their repos, and they're obviously still in a kind of work in progress state. Obviously, they're focused on Agoric and trying to get their stuff working in a good way. So, like, while Jessie is open source and out there, the tooling is not exactly like, oh, I can plug that in, no problem. It also kind of seems like Jessie isn't their main focus, but their kind of more full SES, JavaScript, secure ECMAScript design is what they're really working on, and so don't really want to use something that's not their primary focus. it's a really big shame that even running JavaScript securely is so difficult. Like, we've been doing some research on this in general, and the way that Cloudflare is doing their workers is really interesting. They only use JavaScript isolates to sandbox the JavaScript from one worker from another worker, which is the way that you would ideally want to do it, because it's very low cost. And it is a sandbox. The problem is that, as we've all learned, the JavaScript isolate sandbox is not sufficient for defense in depth. You actually need to have process level sandboxing applied as well. And as far as I can tell, what Cloudflare is doing is applying the process level sandboxing around their whole Cloudflare worker executor. So the workers are only using the isolate sandbox to protect from each other, but then to protect from all of the workers, to protect the server from all the workers, they're doing process level sandboxing on the isolate executor. Process level sandboxing is really dang hard. It's not like impossible, but like, especially if you're doing cross-platform, very hard. Now we could always just say that CTZN only runs on Linux nodes. Not actually out of the question to do that, but even Linux, amongst the different distros, you'll be dealing with difficulties. And again, I'm just not really sure I should be dedicating to introducing JavaScript into our schema definitions. At that point, you might as well just put the logic in the server. Sort of depends. So really, I'm just speculating on something that I wish I could do, but I really can't do. So number 4 definitely is, for now, going to have to be outside of the schemas. It's going to have to be in the server. And we could probably publish the server. I imagine at some point what I'm going to end up doing is taking all of the schema definitions for CTZN and factoring them out into a module, so that all the logic, like this stuff right here, all this stuff will be in a module that's easy for somebody to import. This part right here, number 3, would be nice if it were somewhat automated, but that's also a little difficult. Like, it would be nice if I had a way to say in the comments index what the triggering events were for updating the comments. But I'm not sure that's an option either. We may just need to encode that into the server business logic. If we were to try to, though, and we'll need some aspect of this, for the comments index, for instance, that would be that. For the votes index, it would be that. Arguably, we could update the vote index also anytime a subject of a vote gets deleted to like clean out old entries. But I don't think I'm going to do that. What else do we have? We got the follow IDX. So far, pretty straightforward. That's good. And then we've got the user DB IDX, which would be that. Okay, so far pretty trivial, but we haven't gotten into like notifications. That one's a lot more sophisticated. But perhaps not super significantly more sophisticated. That would be more like this. And probably in that scenario then, we would just index everything that could feasibly be a notification, and then if the user has done something like muted somebody or blocked them, we do runtime filtering, probably. And so probably with the notifications index, so like these four are, there's also like multiple definitions here, because there's, for the indexes, there's going to be server-wide indexing, basically indexing all of the users in your community. But then there's going to be the follows-based indexing, which is indexing stuff produced by who your users are following. And I suppose an interesting question is, like, suppose we merge those together. Effectively, what that would mean is that the server is indexing not just members of the community, like the index we're producing, if we merge the individual users' follows indexes into the server's community index, then a server is actually indexing more than, like, the server's community is actually defined not just by who's a member, it's defined by who its members are following. So if we merge them together, then like server1.com's comments on this post would include pfrazy at server1.com, but because pfrazy is following Bob at server2.com, then Bob's comments would show up in there too. Which is interesting. Sort of puts you in an awkward situation as the maintainer of server 1. Because server 1 would be then in the position of needing to basically police the follows of their users. Like if server 1 has a strict no politics rule, not an unreasonable rule to have depending on what your server is for. Maybe it's a server about astronomy. And Bob at server 2 is super political. And his comments are showing up because I follow him. Now server 1 is coming to me and being like, hey man, you're bringing politics into the server because you're following Bob. That's not allowed. So we really can't merge those together. We really got to separate out the follows-based indexes and the community-based indexes, which is a bit of a shame, but I think necessary. Yeah, I think that is necessary. So folks that are watching, are we making progress? I think we are a little bit. I suppose this means a couple of things. I mean, the way that we separate out the indexes have interesting ramifications. So, like, we got server comments and user followed comments. And then we've got, so how many pairings do we need here? Probably the same for votes. For follows, I don't think we do. I think the follows can be server only. The user DB has to be server only, but that would just... And then notifications could probably be merged as well. Yeah, that sounds right. We might be able to merge votes. Comments definitely have to stay separated into separate indexes. Votes might be more useful to look at if they're separated out. Same might be true of follows. Because like when you're looking at the indexes, the question you got to ask is, you know, basically, if it's a server index, what is it telling somebody that's looking at the server's index? It should be telling them about that server's community. And so for comments, you definitely only want to have the community comments. Same with votes. You kind of want to know, okay, so like server1.com, that community voted this thing up 10 times and down once. For follows, I feel like maybe the same story. Because like you're asking, okay, who in this community follows, how many people in this community, and who in the community follows, so that actually needs to be split. The user database one can be merged. That's no problem. That's an internal detail. And notifications are probably okay to be merged as well, but probably need to be private. Okay, I'll be right back. All right. So I kind of think that these differences of like whether or not it's a community index or a user index needs to be differentiated by the actual schema itself. So like the comments index needs to get split out, I think, into community comment IDX and user comment IDX, or followed. Like I think we need to give different identifiers to those tables. Does mean there will be some overlap. That's something else to consider. But that's okay. We can always just filter out the overlap. Yeah, I guess it does raise some interesting questions about deciding whether to split these things out is an interesting question. There's a cost and a benefit on both sides. Comments, no question. They gotta be split out. Comments definitely split out. Votes and follows I'm less sure of. Feel like they gotta be though. Yeah. We may merge them for an end user, but the thing that you just really have to have is you got to think about the community indexes as being what people see about that community from the outside. And that really needs to be defined by the community itself, not who the users in the community are following. Otherwise, the community index stops meaning what it's supposed to mean. Okay, in that case, let's go ahead and split these out. Like that. Yeah, I think it's got to be like that. Why has it got to be like that? It's just got to be like that. See, now that introduces another interesting situation in my whole triggering events. What do you do when somebody follows somebody? That's a triggering event that requires... Yeah. So that's actually not a huge deal, but it just means that like the comment on added, basically on all of them, anytime the source set is changed, that's got to trigger a reindex. So source set changes mean you're either adding somebody or you're removing somebody that's a full reindex for that given source. Partial index triggers are just an existing source making a modification. I think that's right. This is starting to feel comprehensive. It's super boring to implement, but once it's working, I mean, the implications of all this are pretty big. This is a huge part of how information transmits through the network. I definitely scared away a lot of our watchers this time. What can you do? It's a Monday. Capped out at 14, down to 5 now. Alright, well, let's keep going here. So, community and and follows for comments, same for votes, same for follows. Let's get that done. Nope, here. Let's get my language to be consistent. Why don't we call that a user index rather than a followed index? Yeah. And then we do the same thing for votes. Okay, so that's all the new indexes, or at least the split indexes. Now let's take a look at UserDB is merged and notifications are merged. Okay, so now we need to define notifications. So for this, it's going to be need to know the there's the subject of the notification, there's the origin of it. Or the, let's call it the content. And then there's the created at. And I have to think about how to deal with read and unread state. You can always track that by, like, last time you checked your inbox. So if we just track on every user their last time they check their notifications, then we just know it's unread if it's more recent than the last check time, and we can put that on the account record, I think. So the subject is going to be, let's track the user ID. And then the created ad is going to be a typical timestamp. And the content really just needs to be a URL. So like to fetch the notifications, what kind of information will we need? We just need to know the URL of the item that has generated a notification. And then we should be able to, we may need to actually track, now that I'm thinking about it, the cause of the notification. Because there's a difference between, like, you're notified because you were mentioned in a post versus you were replied to or tagged or followed. I don't know, it depends. It depends on if a given piece of content can create a notification for more than one reason. Let's not worry about that for the moment and instead just track the URL of the piece of content. So let's do it in a kind of simplistic form, and then we can modify it if we need to. Not in love with entry, maybe item. So then, like, how are we going to be addressing the keys on this thing? I think you actually have to use created at so that it's easy to produce, to read out the See, there's another kind of secondary index we may want to automate that we can automate, which is indexed by one of the keys in the object. So what we need to be able to do here is pull out a list of notifications by timestamp. So that speaks to having the key be created at. The key also, it needs to be not just by timestamp, but also for a given user. could solve that by creating a separate per user database, but I don't love that. So that kind of suggests that the key name would be something like user ID : created at. The thing that sucks about that is indexing and de-indexing gets a little tricky. You have to do a scan and filter. For instance, let's say I unfollow somebody and I want to remove everything. Maybe we just don't. I mean, it's not out of the question that unfollowing somebody wouldn't necessarily get rid of their past notifications. It just means you wouldn't be seeing new ones from them anymore. Okay, I think that's gonna be right. Okay. If we look at the server database and its tables, yeah, we actually do need to watch the server database's users table, but that's the only one. So that seems something like there we go. Or maybe, so definitely trying to figure out how to define our indexers in a way that's going to make this all kind of convenient and work well. So it's like, for instance, this dot follows IDX. It's actually two different ones now, so we'll do this dot follows community index. And you'd pass in like this dot and then like a watch definition and then a so an indexer needs to, can actually probably replace, so it needs to know which index it's updating so that it knows which table to look at, but also what metadata to track. So you need to tell it the table it's interacting with or that it's managing. You need to tell it what the trigger events are for updating the indexer, and then you need to tell it how to update the index. those are the pieces that should be sort of repeatable across all of the indexers. The trigger definition is a little tricky because, like, for the oh man, because like it's going to be the users table for a community, but for the it's going to be the kind of users databases list. But then for the individual user, I guess it's always all the databases. So we need some kind of mechanism for, like, basically watching updates to any given table that we're, or any given database that we're loading up, and then on a change, it'd be like, okay, if the change.schema ID is a follow, and change.like database URL is in the users list. That would be the logic there for the community follows list, and then you got the logic for updating the follows list, which would be basically this right here. And then for the individual user follows bit, we probably need to be creating per user private databases on the server, unfortunately. Because we want the entire data set to be readable externally by HyperCore. So we can't just put it in the private server database. It needs to be in a private per user database. And that's the difference there. It's just whether or not the changes in one of the, yeah, okay. So then, like, our server is going to need to load up the Hyper-V databases for every server that users are following, as well as every user that they that is either on the server or followed by one of the server's users. It's a lot of Hyper-Vs, but that's the only way this is going to work. I'm going to stretch my legs. This is by far the hardest piece of the entire design, so it's no surprise that it's taking a little bit of difficult work to get done. So, Yeah, I think we need to introduce private private user databases. I think that's going to be a requirement because basically every user is going to have their own indexes. The votes, the follows, the comments. And I want to make sure that end users can potentially synchronize those private databases without sharing them publicly. So the server could tell the user what their private user database is. It's one that the server is maintaining on their behalf, and then they'd be able to read against it after pulling it down. So that means our user DB is going to have to modify to be both a private user DB and a public user DB. Then we need to update our database manager to load up all these different types of databases. And not only does it need to be modified to load the private databases for its own users, but it also needs to be modified to load the public server databases of servers that are being interacted with, as well as the public user databases of users that are followed. Okay. So how do we want to dig into this? Probably step one would be to comment all this out and temporarily just rename these indexes, but not follow through on redefining them, because what we really need to do next is get our database management updated, starting with the public and private user databases. Hey Stefan, welcome back to the stream. To catch you up, we are introducing secondary indexing to the system, which is requiring plenty of work. I am currently introducing the idea of private user databases to store their private indexes. And then we're going to start to introduce the secondary index executors. And along the way, we need to introduce the ability to load databases from other servers than the current one. But first things first, the private user databases. It is indeed a complex refactory. Not my fave. Okay, so that introduces the private user database management. And doesn't need blobs. Currently doesn't need any tables. We'll introduce the tables later. And now we just need to introduce basically anytime I leveraged user DBs, I need to change that to public or private. Okay, let's see if that passes our tests. Should be a relatively simple update there. Of course, no. What have we got? Close is not a function and watch of undefined. That may be something I was futzing around with. Yeah, okay, so that's... Okay, private DB URL is not getting set on the new database, on the new user accounts. Let's see why. Private DB URL is there. Oh, needs to be over here. So let's gotta do the same thing I did there. Okay. So let's just commit the addition of the private and public user databases. Okay, introduce private user databases. Hey Lars, more stuff in push. Tell me about it. So now that we have the private user databases, we can add their tables, which would be follow user IDX, and it would be comment user IDX. Now, let's see. Do we actually need to separate these index definitions out now that we're using private user databases? I don't know if we do now. And it's certainly cleaner if we don't. So I'm going to remove that. I'm going to merge them back together, which should be doable by just checking out some of this stuff. Okay, so I'm going to remove okay. So those are the indexes we store in the private user database. Gut check. Are we sure we need to make these private? Probably, right? I mean, how damaging would it be to show those secondary indexes in somebody's public database? Well, one thing to consider is that the private user database will always be maintained by the server, but the public one wouldn't. So if we want to take advantage of the indexer, it sort of has to be this way. Yeah, it does. In fact, have to be this way. All right. So next up, we need to add the index state table, and we need to add these to a couple of different tables. In the server space, we need that on the public and the private server databases. And then the notification index, maybe that only goes on the private user database and we maintain it. Yeah. That seems right. So now we're back to how we're defining our indexer. So we're going to have this create indexer method. looks something like that. Don't know if we actually need to save the indexer. And it's gonna look something like that. There's a couple of things in here that are not, like this right here, the follower ID being passed in. That's going to have to be worked through. This bit right here, obviously, need to figure out how that actually works. Need to figure out a lot of things. Need to figure out, for instance, how watching works. How do we detect when changes occur? So that's some Hyper-B low levels we got to think through. Might be a good place to start. Yeah, that's probably a good place to start with this. Mention how much I was dreading this particular update. Hey Matthias, are you in the chat? If so, say something, because we're about to get into some Hyper-B details. So basically, for every database that we load, we need to be sitting and watching for changes to it. And then when we detect a change, we need to basically do a diff on the database. So something around right here. I think we're going to want to watch, the methods we're going to want to use is on the hypercore probably like on append. Yep. And we're going to want to run this logic also after the initial setup. So when a data update occurs, we're going to go through all of our indexers. And we're going to want to get the current state. No. Can't do it from here. Can't do it from here. Needs to be in the database manager. We need to maintain a master list of all databases that get loaded. I mean, basically what we need is that anytime a database gets updated, one function that's detached from the given database instance needs to be run, and then it needs to cycle through all the databases that we manage. Hey, Math. I figured out what I was asking for you for, but good to have you on the stream. All right. Okay. We need a watch function. That will always trigger immediately, as well as watch for feature updates. And if it is a database which we produce secondary indexes from, it needs to be watched. That would be the public server database and all public user databases. Does it need to be the private server database? I don't think so. So just the public ones. And that watch function should pass itself. So now we're watching all the public databases for changes. And when a change occurs, we need to basically diff all of the record changes No, it's more complex than that. We need to find all of the interested indexers. That's what we need to do. And then we have to give them a chance to look through the changes and determine whether or not they're interested. So that means basically every database except for the public server database needs a chance to look. So it's like for let db of all dbs. And here we go, taking advantage of function generator functions. And then just gotta do kind of a pseudocode thing. Knowing whether or not you're indexing a database or need to update your indexes is a little bit complicated. For instance, for the public, for the private server DB, that's only interested in the public server database. Because all it's doing is updating the user database index. So in that case, it would be like, you know, return DB. That would be like that. Is the public server database? And it is, yeah. For the public server database, it would be, is it a user DB? Is it a public server DB? And is it one of our users? And for the user private database, it would be similar, except that it'd be like that. And that just tells us if we're interested in looking at the database in the first place. After that, you then look up, you go through each of your indexes, and you look up the current state. And you do a diff to pull out all the changes, and then you update accordingly. Oh, I hate this code so much. I hate this particular task so much. This is such a pain. I'm really struggling to unify it. Man. We could simplify our logic at the outset. Hey, Mike Mullins. Thanks for joining the stream. Now, we could simplify our logic at the outset by not doing this. Well, I have made a to-do list and broke it down. Did that earlier in the stream, and it looks like this. So this pre-pass here about whether or not I'm indexing the given database is kind of an optimization that we can take out. Or just merge into. Just kind of manually code this really quick, and then I'll generalize it. That is accurate, Michael. So the change is going to look like what? It's probably going to look like. Actually, I need to see what that looks like before I can. I'm going to assume that key is going to be the full path with the separators. So then the so there'll probably be a UTF-8 given. Yep. So I'm going to be splitting by null, which then should mean that the scheme ID is the first key segment. No, it would be the 0th key segment because it's not preceded by null. I am doing the incremental indexing. So this is the moment where we do like if this dot indexers dot is interested in change, then this dot index. And to make that determination, it needs to know the database, and it needs to know the schema ID and the change itself. I think that's accurate. Oh, gosh. Complicated, though, because, are we interested in the change? Well, for the private user database, I need to know if the database that I'm looking at is being followed by the user. And if it is, okay. Okay, I think I know how to do this. I think we need basically to have a way for databases to subscribe to each other, more or less. Requires information to cross the database boundaries. But it means that basically for a given database, we have some kind of way to do this. So the private server user database needs to know the public one, and then it's going to have a way to get subscribed. Yeah, I can, but this is more complicated than that particular problem. This is going to solve it, though. Now, pump only calls the last parameter on an error. Oh, does it, though? Or is it always when it's done? Huh. It might actually always get called, but perhaps I've got other code that does this way when done. Then I've got erroneous code, I think. Yeah, right here. Probably the resolve gets called before the reject, and so it hasn't manifested yet. That's funny. Yeah. This is kind of pseudocode anyway, but did you see what I just changed there? I had a list function that was doing it wrong, but the resolve was, yeah, the timing came into play. Not a good reason to leave it, though. Yeah, if they're getting scheduled by ticks, async ticks, then yeah. Good reason not to leave it. Okay, but so here's how we're going to do this. We're going to first write a function on each of the tables that looks like this. So for the private user database, we're going to look at their follows on the public one, which will pull out subject.db URL. So that's pretty straightforward. This is debug pseudocode that should get removed. The public one, public user database, doesn't subscribe to any others. And then in the server one, the private database is only interested in the public one because all it's indexing is, is it? Let me think. It's going to be interested in all public server databases, so we'll have to think about how to construct that later. But for now, we're just going to pass in the public server DB. This is getting into some slightly what you might consider incestuous state passing, but we're going to live with it for now. And the public one is interested in the users list. It's going to do similar to this, except it's going to be this.users.list pulling out the DB URL. Okay, so now all databases declare their subscriptions, so to speak. Which databases they're interested in. So then, in our on database change, we actually have to fetch this every time a change occurs because the list is dynamic. So that's how we know whether or not to run the index function. That's our first pass. Okay. This will probably change over time, but it's a start. That encompasses this logic right here. Now the update index is bit. Let's get back to our kind of pseudocode thing over here. what we now know is this is similar, but we now know that it is a database that we're interested in. So the only filtering we now need to do is based on the change schema ID for the given index. So this just becomes this. Are you interested in the table that changed? And if so, run the indexer. And then after that, we then update the index state for each index change. So this can't fail. This can only fail because the change is somehow malformed, which means it should be an abort and drop out. Looks right. This thing is not efficient right now. We're just going to have to look at that for the moment. So this actually needs to go up into the base class. ACS, welcome back yourself. Oh, man. It's almost hard to believe that we may be getting close here. I almost don't want to believe it. How much core functionality is missing right now? Will you launch alpha if it's missing some extra features? Yeah. The MVP of this thing is to be a decentralized social network. So we will launch with some missing niceties around the social networking side of it, so long as the MVP of the decentralized is there. Probably what I'm going to do is get like a quote-unquote testnet going. Because we may need to make breaking changes to data schemas. So probably get a testnet going, and then we'll plan obsolescence for it, and then, you know. That class is very minimal. So let's test out our new indexer on the private server database first. It's snowing there. Where are you at? In Sweden. That seems kind of normal for Sweden, right? Right. Yeah, we got a ton of snow for Austin a couple of weeks ago. Like snowman levels. So we still need to have a way to manually trigger up index updates. But we now have the basics. That snow was super weird. Ryan's in Austin as well. Okay. One of my tests involves lots of users. I think it was follows. So let's see what happens when we run the follows test. Could have sworn I installed Java globally already. Guess I didn't. The number of ways I'm sure that the code is broken as it currently is enormous. No tests found in unexpected resolved word. Reserved word, rather. Hell, that means I've got a wait in some function that doesn't have async set on it. Where is that going to be? Ah, update indexes. That's fast. Right here. Okay. Can read property feed undefined. So I'm watching. That's happening because I'm calling watch, and I must be calling watch before setup is done. Give me a stack trace. Line 28. Ah. Okay, what next? Can't read property URL of undefined. I forgot to pass in the public server database into the private one. Oh, right. No, different one. Here. So private server DB. Okay, where are we? So I need to overload the constructor for this. Need to fix that over here as well. If anybody's curious, I'm not 100% happy with how the code is evolving in this commit. There's definitely some state threading between the server, between the database definitions that I'm really not in love with. For instance, you know, passing in these databases to each other. But for now, it is what it is. Yeah, we'll have to improve on those pieces as we go. Okay, what now? Can't read ID of undefined. So that's in the private server database. Let me find the second or third time. It'll take some refactoring as we go. So this is in the user database, line 26. I'm guessing notification IDX is wrong somehow. It's line, yeah, what's wrong with that? CTZN.network/notification IDX. Notification IDX, it should be right. What is it choking on? Line 182 in base. Oh, it's undefined. find. So schema is like, so it is failing to load the schema or to get the schema. Why would that be? Our notification index is not loading for some reason. Why? That's why. Get subscribed DB URLs is not a function. I swear it's a function. Should I change the name or something? Get subscribed DB URLs. Is it ever a function? Oh man, wait. That's getting yielded out. That's the problem. Should be db dot. Okay. When you for of and a map, it comes out as an entries array. Okay, so some progress. What's it choking on now? Let's provide subject user ID or URL. Line 49. So when it tries to do follow. Huh, okay. What did I screw up there? Oh, it's because okay. So our index is not getting updated. So now that the index is failing, we're getting those kinds of error cases. So let's thread through, because we should have seen at least something occur. We should be seeing, what we're trying to get now is some logging to occur. In fact, I'm going to modify our tests to avoid some of the pain points here. Because really what we need to do is just see if some of the stuff during the setup over here, there were triggers. So it's just going to chill for 3 seconds. Okay, and now that fired. So now let's jump into our database code here and start looking through why on database change doesn't seem to be happening. so that did get hit. Okay, and let's modify that real quick to see if it is firing, because I have it firing automatically on first watch call, but let's see if it's actually firing on the, it is. Okay, so that's so far so good. Now let's take a look at the subscribed URLs logic, make sure that's working correctly. Okay, that's working correctly. Yep, that's looking good. It's even increasing the user list as we go, so that's good. Yeah. Yep, okay. So then, is this part working? Okay, yeah, exactly as it should. Good. So now let's look at the update indexes logic. Yeah, this is probably where things start to break down. So let's take a look at the changes. So that's coming out with nothing. And why is that coming out with nothing? So 8EB is our public server, so that's fine, but the create diff stream's coming out wrong. Why would that be the case? Is it? Let's say for the sake of experiment, I wonder if it's possible that the create diff stream doesn't, it should, but what are the odds that it doesn't handle subkey spaces and I need to descend into the subkey space, so to speak? No. Hey, Math, you on the stream still? Gotta figure out why create diff stream ain't pulling anything out. Pass in one. I know that surely the changed DB actually has changes in it. Let's see. It has users. I'm gonna have to add math real quick. Let's see what happens if I do create history stream. See if that actually gives us output. That does give output. But diffing doesn't. Well, I don't know if that's a problem. We could just use the history stream. Don't know why diff isn't working though. It's too bad. Okay. Well, we'll do that, and okay, sequence always starts with 1. That's actually good to know. Or does it? Is there sequence 0? No. Okay, that's actually quite good. So now we're making progress. And I think probably our problem now is that change scheme ID is being incorrectly put together. That should be like that. Almost. Okay, so that's getting closer. Getting real close. So now that we know what the changes look like, let's take a look at a little more depth. Okay, so now let's look at the index definition. Should just be logging the arguments, so failing is probably just that. Yeah. No, okay. We should output the error. Index ID. Right there. Okay, making progress. So now, let's just define this a little bit right here. And so here's where we hit some of the tragedy of this design. That right there. don't have a mechanism for that. These changes tell me... I know if it's a put because it'll have a value. I know if it's a delete because it won't have a value. But I have to figure out more about what the change is. For instance, there are two kinds of things that can happen here. We could be we could be removing the record, the user record. We could be updating the URL, or we could be updating the user ID. What would be good is if we could load up the previous record. Let's see if the get method has a way. You know what else would be handy is if I were passing in the key. Does Hyper-V have a way for us to get an old value at a specific sequence? I think I can do that by doing a checkout. Uh-huh. So... I want to look up an old value, which I think I can accomplish this way. I think that's it. db.checkout is not a function. I need to actually call like this. Interesting. I don't think the checkout was right. Because it's pulling out the old value, which is actually the current value. Sec plus 1. Does that mean I need to subtract by 2 then? Yeah, Matthias, you see what I'm trying to do here, right? Trying to get the old value for the given item. So I know the sequence number of the update, so I need to get the 1 right before that. And if I subtract 1, it was giving me the current value. To get the one immediately previous? The value immediately previous? That seems to be working correctly because old value is consistently null. I'm not remapping in any of these examples. So let's find out then why the log is, or the update is failing. Change.value, and it needs to be user ID, not change, not username. Okay. So that needs to construct the user ID. It's a sequence number. It basically tells where in the history that thing happened. Okay. So far it looks correct. Should be able to restore the tests now. Only question is whether or not we have a timing issue, which we may. Indeed we do. Yeah, I would have expected it to not be... I would have expected to have to subtract by 1 in this case, Matthias. So something is failing and not telling me why. The version is the length, sec is the index. But if I'm doing a checkout, am I checking out? I'm checking out by the index or the length? Ah, I see. It's a little confusing, but understandable. Now, why the F is this thing blowing up on me? Well, let's fix our known timing problem, and then we can worry about why it's dying without explanation. So that's the start point, and then in the server we have the index point. And the index point should never, ever, ever happen after the start point. And indeed, it is occurring after the start point. So the problem we have now, the indexer is working as expected, which is great, but we have a timing issue. Because if we look at the watch functions being called, that hits on database change, and then it runs our indexing process. But we need the indexing to finish before everything starts. And this gets into the domain of needing certain indexing processes to finish before moving on. This right here. We need to await the indexing updates before we move on. Now, it's not related to the CB this. So to explain what that is, Lars, when I call watch, I'm immediately triggering the watcher as well. That is intended to catch up on startup to go ahead and look through all of our indexes and make sure they're updated. Maybe I should explain that in the comments. So the interesting thing about this is I need a way to say await until all indexes are updated around certain indexes. So I'm going to use the bathroom real quick and then we'll dive into that. I should call my bathroom breaks GC pauses. Sounds like an inverted promise. That's what my doctor said. But I don't like to talk about that condition. Let me get some music on and then we can... Went to the doctor and he told me I have a bad inverted promise. It's gonna take some surgery. Well, could do that. So that would just be like, like that. And then I'd have to probably work around the shape change. Except I don't have the sequence number of the... No, I don't actually have the sequence number of the old change. I have the sequence number of the update, which, so if I ran that, I'd be getting value information I already have. The point of doing the checkout is to take advantage of the Hyper-B to find the previous value from that point. Now, if we were doing the... Alright. Anyway. Okay. I'm going to check in on all of my communication real quick. Make sure nobody is desperately trying to reach me. Okay. So, basically, we need a way to wait for the indexing to happen around this update right here. And maybe the way to do that is... So there's like two ways that indexing can get triggered. It can get triggered by the watcher, as we are currently doing it. But there are some times that we actually know that the update occurred because we're the ones running the put. And so in those cases, what we could do is trigger this function right here manually, which would mean that the watcher gets triggered redundantly. Wouldn't have any effects, but it would be inefficient. I mean, we could do this right here. Let's see if that fixes our bug. Yeah, so there were more index runs that way, which I'm assuming indicates, yeah, that this is accomplishing what it should. So our bug is not, this whole RPC stream destroyed is occurring for something other than the index being out of date. In fact, we can generalize what I'm doing here. Or not, doesn't really matter. Could just always choose when to basically wait for a database change to get processed by manually calling this. I gotta figure out why this thing is throwing and dying like this. What is doing this to me? Maybe what we're witnessing here. Alright, catch you later, Math. Huh. Yeah, maybe what we're witnessing here is, oh, this might actually be like the watch emitting something. Or something late related to watch. Like if I remove this right here. Yeah. So that exception that's getting thrown, it has to do with some kind of cleanup that needs to occur and is not currently occurring. I wonder. Yeah, so this has to do with the client not gracefully closing those streams that were created for the notifications for the event here. But I do believe cleanup is getting called. So something is wrong with cleanup. It's the hyperspace API that's choking on us. So close is getting called. And hyperspace cleanup is getting called. And client close is getting called. So I don't know why it's complaining. I wonder if that's a bug in the hyperspace stack. No, it's because of the event handler. So basically, we have an RPC connection to the hyperspace server. So whenever you're listening to an event, it's opening up a stream to the and using the stream to push down updates. And that stream is getting prissy with us. And it's unclear to me why. We're using the simulator. It's kind of frustrating. I might have to bother Andrew whenever he's around for help on that. So for the moment, I'm just going to suppress that error. Huh. It's like it. Yeah. So it's just upset that there are streams still. Okay, wait a minute. We may be able to figure this out. So let's look at the hyperspace client real quick. When you call, so it's this event emitter, and when you do this, it this code is a little bit difficult to jump into. Not criticizing, just a little difficult to jump into. It's not the core store, it's the remote. What is the cleanup that is failing to occur? Pretty sure this is a bug in the stack, so I'm gonna go back and just suppress the error for now. Because I really don't want to be contending with that. Okay. So we need to test some of the specific behavior around users here. Well, we could do that, or we could save that for when we actually define registration and profile migration and just keep defining our indexes. Let's just take a look real quick and see if one of these data outputs looks right. And then we'll continue with our indexes. Okay. Let's continue migrating our indexers over. So next up, we're going to have this one's done. Looks more or less correct. So now let's get these. We will start with the follows one. Why not? So, same as before. I'm going to export this function. And in our follows API, we're going to import it. And manually trigger and await the database change rather than doing this. Yep. So now, in this definition, there were a couple of things there that we were passing in that we don't have access to anymore. In particular, the follower ID. So to find that, we need to this would figure. We need to be, we know that we will have the public database URL of the public user database URL, which is that right there. And we need to map that to the user ID, of course. And that index is, of course, on the private server database, right here. Actually, not a problem. We have a function for this, I believe. Right here. That's user ID. The state threading is pretty awful, but I'm not going to sweat it. That should work. Let's find out. Indeed, it does not work. Can't read properties subject of null, line 19. That was a lot. Holy cow. Yes, it's because it was a delete. How did we handle deletes previously? Okay. We were cheating, so similar to what we were doing before, if it's a delete, we need to pull the old record, which looked like that. So we'll be able to have delete. Should handle deletes, yeah. Still failing. In fact, it looks like the like we didn't error on the delete, but we didn't work correctly either. Okay, let's see. We're failing on line, what, 82. And that's when Bob is... We're failing on line 82. Is that right? Oh. Yeah, so, yeah, I mean, Hyper-V is a normal key value database where you can put and delete. Deletes are, but internally they use an append-only log. That said, there's no reason that deleted values have to stay kept alive in the system. So if you don't maintain the history, it'll go away. So we don't have a strong guarantee of deletes, necessarily. It's kind of up to the network to forget history. And I do agree that that is not always great. Yeah. And, you know, you should be able to track down, you know, by IP who's rehosting all data, so... Okay. This is tricky. It seems like I'm, you know, why would it be failing where it's failing? Something's wrong with the index is really what's going on here. Prior to the deletes even being processed. Yeah, the index is not being formed right in the first place. Let's just log real quick. Let's log what we're writing. So none of our writes are correct. Oh, because I've got this old stuff. Okay, that's no problem. Actually, no, let's not do it that way. Let's do it like this. A little more reliable. Hey, there we go. We're in business. Or not. Interesting. What just failed? Seems a lot like a timing issue just revealed itself. I think we have a timing issue in which logging is affecting the timing results. That's not good. Ugh. line 103. There's definitely a timing issue at work here, which of course manifests as being hard to reproduce. There it goes. Let's see if I can get some clarity about how the timing issue is occurring, because that's exactly why I'm triggering the index right here. So this shouldn't be happening. Maybe I'm failing to await somewhere. Now, of course, the console logs could affect it. No, there it goes. Great. Yep, right there. A couple of interesting things going on there. Okay. So manually triggering the index update is not accomplishing our goal. Let's look into why that might be. That would be why we're not awaiting. Yeah. If I do this, it should be solved. Okay. We're going to have some definite performance optimizations to do, because this indexing code is not ideal. We have redundant work occurring with the manual triggers. We have all sorts of fun stuff that we got problems with. That's just how it goes sometimes. Okay, so that's the follows index updated. Now we just need to do comments and votes, and we'll be back to where we started. Isn't that exciting? I know that's what gets me out of bed, is working for 4 hours to have absolutely no appreciable difference. So what I'm referring to is that the work that I've been doing here today is, no, I didn't paint myself into a corner. Basically, I had some temporary approaches to how some of the pieces were working, which worked fine at the outset, but we're not going to handle the distributed network correctly. And so now we're implementing some stuff that is, you know, correct. And that will all be fine. It just takes a little bit of work. Alright, so on so when a comment is created versus deleted, we just need to know the subject URL. Let's see how long has change type value get used just to know the subject URL. So Okay, that should be comments done. He says way too optimistically. Later, Lars. Thanks for joining. I'm in agreement with you that we do need ways for people to forget. Sometimes deleting stuff does need to be a thing. And I will be building things to the best of my ability to make that the case. It's going to be a back and forth. But just because the hyper system is able to pull history doesn't mean that things should be designed to always do that. Okay, so I did something wrong in the indexing. And it's basically turns, our situation really just turns the problem into a social problem. Because it becomes possible to retain history, but not required. Okay, we've got should be a string error occurring somewhere in here. Let's improve our validator a little bit. I mean, I think everybody here can think of a time when they accidentally posted something that's incredibly embarrassing and they didn't really mean to. Data path. Or they post something embarrassing and realize, oh, I shouldn't have said that, and I remove quickly. Okay, that's our problem. Change that URL. Yeah. Flexibility is the name of the game. In pretty much everything that I, in my mind, everything that I build, it's about flexibility. And not everything can be flexible. You have to make trade-offs at certain points, but like, there's definitely not, I don't have any kind of thing like, one person should always be in charge, or one model should apply for everything. The best design for all this stuff would be a high degree of flexibility around how all this is designed. Should be a toolkit. Kind of like how the web is in many ways a toolkit. Every one of these changed URLs needs to be replaced. That should do it. Okay, line 92. okay. Yeah, I see. I think I see what's happening. I think deletions are not being properly handled. Deletions aren't even getting indexed. Am I failing? Failing to await. There we go. Brittle? What makes you say so? That's comments, and that leaves one more. Votes. Get the votes done, and then we are back to where we were with our new indexing code. And then we can start to implement new indexes, like notifications, or the user-specific indexes. All right. Couple of similar needs here. And then what do we use in this? Just subject URL and the vote. So we need a value, but only if we're putting. If we're deleting, we just need the subject URL. That's fine. Okay. almost can't believe that we're going to get through this because this was such a pain. Didn't work. Line 48. So basically nothing got indexed. Let's make sure I awaited. I did. That's part of our problem. There we go. Let's try running all the tests. How about that? One step closer. That one was tough. Let's do some review. Oh boy. Oh man, oh man. That one was tough. So now we need to introduce, I believe, these indexes. The follow based indexes. Which includes notifications. Which is probably how we'll start. I'm going to stretch my legs before we dive into this one. Okay, notifications. Let's try to knock this one out and then consider that our closer for the stream, I think. What are we up to here? So we started around 11. 4.5 hours. Close it out with one actual feature addition. Seems good to me. So, let's look at our notification schema here. Subject ID, a little vague. Also not necessary anymore. So notifications are now per user database, so we don't need that. We just need to know what it is and when the notification was created. Okay. So this may actually be pretty easy with the facilities we have. If we're really lucky, this will be like a home run simple task. So we're interested in follows and comments and votes. We might someday also be interested in posts if we introduce mentions, but for now we're not. Probably more accurate to say when we introduce mentions. And that lock needs to be actually specific to this user. So it actually needs to be like this. So this will get triggered anytime a follow, a comment, or a vote occurs for a user that you currently follow. It also needs to be for when it's users that are on your servers. Oh boy. Of course it had to be hard. It can't just be followed people, can it? It needs to be anybody on the server as well. Which is basically every user. So basically we're always interested. But it would be good to know if that, well, no, I think we're just always interested. So this right here is just always true. No, that can't be the way. No, because that would be chaos. It's anytime they're a user in the community that you're a part of, or when they are somebody you follow. Alright. Of course, returning true wouldn't have worked anyway, because it has to return a list of URLs. Alright, well, it's just going to be inefficient for a little bit. Optimize later. So the private user database, anytime that's created, it needs to be given the public server view. Yep. That's that definition. And then the actual notification index. There's puts and deletes. So basically we need logic around determining if whatever it is that we're talking about here, whatever it is that we're looking at, is relevant to the user, which will be a schema by schema thing. And if it is, we add it. Interesting question about this is we don't... I'm not going to delete old notifications. I'm just going to let them stay in there. So if it's a delete, we don't process it. Count once out. Be right back. So if the change dot key parsed will switch that, and it'll be, except we do have to handle, well, I don't really want to be told when somebody unfollows me, so we're not going to worry about handling unfollows. It's nice not to say anything when that happens. And the value is always the same. So really all we're doing is checking to see if it's relevant to the user. if change.value if it's a follow, it's going to look like this. So is this db URL is equal to this .url. We're actually invalidating, or change that. We'll just do it by db URL. It's not. Okay. If it's a comment, then we want to know if the subject URL or parent comment URL are on me, so pretty straightforward. And then we just have the notification, which is an item URL and a created at. Okay. So now we need to trigger, make sure that database triggers are, database updates are triggered. For votes, they are. I remember comments, yes, and follows, yes. All right, let's run our test real quick to see if anything broke. Later, CS. Thanks for joining. Still got some errors here. Can't read property starts with of undefined. Line 52. Oh, right. Parent comment URL may not always exist. Okay, that's looking good. So now we need a notifications API. Why don't we put it on accounts? No, that's not right. We'll just add a notifications API. And for our debugging, we'll start by just dumping that. And then we will eventually need to set up code to go through and load the actual records for each of those. And let's pull from this one. No. Which one? Let's pull from follows. So we create a bunch of users, and then we're going to have the users start following. Have everybody follow everybody. And we'll have a couple of posts get created. And likewise, a couple of comments. But we'll have those comments and those posts get created by differing people. So we don't want want to make sure that we're not having got to make sure that notifications are only for the people that we intend. And then let's create some votes. We'll make Alicia an upvoter and Carla a downvoter. It's very rude with Carla, but she really doesn't like everybody on the server, so she's just gonna downvote everything. Okay, so that's our test data set. And let's just fetch the notifications. And see what they look like. And it is just empty. So let's see here. So we got lots of changes detected, but it looks like none of them getting indexed. You know, we've got some redundant indexing occurring, it looks like. Do we? Definitely seems like more than should be. I'll have to look into that later. But yeah, nothing's... Some of those should match. Nope. It should be not... Should be the public user DB that it's looking for. So... There we go. Except it's failing. Follows IDX entry. Yep, okay. A couple of problems. This runs the risk of collisions on the key names. So we're in business. Except we got some posts showing up that shouldn't be there. That's odd. Oh, no, it's not post. It's a vote. It's a vote with a... Surely I'm not indexing that way. Oh, I am. Ush. Yeah, I am. Ugh. Alright, well. That's a bummer. Alright. We're also definitely getting more than we should be, I think. Yeah, we're getting duplicate entries for sure. Well, we'll worry about the duplicates in a bit. For now, I'm going to go over to this and have it fetch the values of the notifications. So that's going to be Item is consistently null. Ah, there we go. Okay. Okay, we're close here. We're getting data out, but we're getting duplicates. Looks like 2 for every one. So we gotta figure out why that is. I'm guessing I was seeing it inside the indexer process. So pretty sure, I'm gonna double check that. Yeah, we're definitely having duplicate index passes. And that's because, I know why that is. Shoot. It's because our... Well, no, it shouldn't be happening. That shouldn't be happening. Which suggests to me... Let's take a look at our index behavior wrapper, because it suggests to me that our create history stream is ill-defined. This is going to be a total nightmare to look at. Indeed it is. We can help ourselves a little bit by only logging when the scheme ID is the notification one. See, that's not good right there. The index is going backwards in time. We need to lock it. That's our problem. So yep, I think that solved our duplicates problem. Okay, good. But what is... why would this .url not be set? I guess we need to make sure that... so key gets set where? Here. If I move that there, does that fix that bug? Huh. How does that happen? Ah, okay. Okay. appreciate that, Robert. Lag is okay at the moment. Okay, let's spot check all these notifications real quick. And then we'll just add the automated test for them. So the first one that we should get is comment 1. That's correct. Next one we should get reply 1. That's correct. Then we should get comment 2. Now reply 2 came in. So I'm getting a notification for your own content. That's not right. Should be easy to fix. Go to the index handler here, and then we just need to see if db.url is equal to this dot is equal to my URL. So that was reply 2, I think, that we want to ignore. Yeah, so let's see if that fixed that. Yep, good. So now we should see how many upvotes? 2 for posts, and then 1 for a comment. So that's 1 on a post, another on a post, 1 on a comment. Likewise for downvotes, I believe. 1 on a post, 1 on a post, and 1 on a comment. Okay, so notifications is working. Woo! I think that all is exactly where it should be. We could, you know, fetch more information on some of these. I'm not going to do that for now. I'm going to reverse true. And then I'm going to go through and write some tests. So how many should there be? Boy. 1, 2, 3, 4. You know, we'll make this easy on ourselves. I spot checked this data and it appears to be correct, so I can work off of it. So 9 of them. Next one is on the, let's see, posts. Second post, and then on the first post. Then it should all be the same, but this time I'll upvotes. And I should include... you know what would be good would be to have information about the author of these. Okay, so I'm going to go back to my notifications API, and I'm going to have author, user ID, yeah. That's all the upvotes and downvotes. And then we have the comments. So number 6, subject URL's right. There will be no parent comment. The text will be comment 2. The author of comment 2 is Carla. Next we have reply 1, which has a parent comment URL of comment 0. And that is by, let's see. It's by Carla, so that's good. And then finally we have comment 1. Love writing tests, which I believe is by Alicia. Yep. And that should cover it. That's it. That's notifications. Okay. So we've got the notifications index and an API for it now, which is all good stuff. So tomorrow I'm thinking we'll dive in with that as our starting point. Much nicer starting point than our starting point was today. And we'll get the UI for notifications done. After that, we get into the user follow indexes, which are these right here, not yet defined. Not terribly difficult to implement. But the trick with those will be merging them together with the other result sets, which are an interesting question about how we want to deal with them. But Yeah, we may have to change some of these details. I'm thinking through some of the pieces. It's going to take some work. We're going to go back and forth on a couple of these decisions, but we are making forward progress every time, so that's good. I'm thinking about things like how to deal with notifications from other servers. It's going to take some thinking. Yeah, it is going to take some thinking. All right, well, I'm going to call that a stream, but we'll pick up tomorrow with implementing our notifications UI. And then really we're going to be getting into the zone of testing out our multi-server synchronization and interactions and things like that. And that'll be pretty soon. Hopefully by the end of the week we will have a pretty solid working foundation for all of this. Like we ideally would be in testnet territory by the end of the week. So thank you all for joining the stream, and enjoy the rest of your Monday evening. I'll catch you on tomorrow's. So have a good rest of your day. Bye, everybody.